Hello, everyone, and welcome back to the Cisco Optics Podcast, where we talk about pluggable optics for networks. Cisco's 8000 series router changed the game in high-end routers thanks in large part to the Silicon One ASIC. It also introduced to the industry some of the first 400G ports along with Cisco's QSFP-DD form factor pluggable optics. This is episode 32, and we continue our conversation with Ammar Khan, product management leader for the 8000 series router. In this episode, we talk more about optics and routing and why the introduction of 400G was such a big step. Ammar received his BSEE at the University of Oklahoma and an MBA from Santa Clara University. He started his career as member of the technical staff at an ASIC emulation startup where he worked on cutting-edge ASIC and FPGA designs. His first foray into networking system design was at another startup based out of Massachusetts. He then moved to Broadcom through the company's acquisition and launched and managed products with over $250 million in revenue. In 2010, he moved to Ericsson's IP division and defined their edge router line with an annual revenue of over $150 million. Ammar joined Cisco in 2018 and has been with the 8000 series router team for over 4.5 years. He's worked on various areas of the 8000 product line, including fixed and modular systems, line cards, fabrics, optics, platform security, and more. If you haven't already, please subscribe to this podcast. On Apple Podcast, you would click the plus button at the top now. We're part of the Cisco Podcast Network. Check out our blog at blogs.cisco.com and search on hashtag Cisco Optics Blog. All one word, no hyphen, and no spaces. You'll find podcast notes and links there too. For our YouTube playlist, go to youtube.com and search on Cisco Optics. And for product information, go to cisco.com/go/optics. And now, join me as I talk with Ammar Khan. So I'm still trying to understand better what changed at the time that the 8000 router came out. So it sort of coincided with what you're saying about Silicon One, the chip. It coincided with when 400 gig started to emerge. And also the coherent optic being a pluggable instead of like a line card, right? Or a larger module. Is it? And you were also talking about the larger footprint and the fact that a lot of data, there's more data that's extremely valuable, mission critical, right? Is the data rate the thing that push things over the edge? Like, is it that now that we're at 400 gig, if one module fails, that's a 400 gig link, right? That's a lot of stuff that goes down all at once. Whereas, 10 years ago, if your 1 gig SFP goes down, well, it's 1 gig of data. Right. So it's,
I mean, data is data, right?
Manageable.
You're right. I think what you're saying is absolutely spot on, right? So we have to look at the environment that we are in. And that to me also is very fascinating. The innovation is happening everywhere, in every parts of the network, right? If you go to access, there are new technologies being introduced where you're increasing the copper speeds, accessibility, right? DSL is going through a lot of transformation. New access technologies are getting introduced. You have 4G, 5G. I have no idea what other G is in around the corner, but I'm sure that's going to go up. So you have IoT type of services. And if you go to Verizon and if you look at their annual report, there is tremendous amount of value in IoT platform that they have and other people are introducing. That's massive amount of data that is coming our way, right? And that needs to be sorted, needs to be organized, and you need to, figure out, make some intelligent decisions based on that data. And then you have another data which is inside the data center, but obviously it's impacting traffic everywhere. And that is your AI ML clusters, right? And they are growing in size. And to me, it's a very interesting problem. It's data begets data. They need more data to process to be able to give you better results. And that means you need to feed more data and you need to continue doing that. And then it has granularity, right? Yeah. So you could run an AI ML cluster on a group, on an individual, on a person, on a laptop. because everything is generating data. I am generating data when I am, on the web, or when I am in Facebook, or
Hmm.
if I am logged in. So I'm generating data. So somebody can just simply take that data and process it and make some intelligent decisions out of it. I'm sure Facebook does that. They do know that I like online shopping, and I get so many ads on,
Oh yeah,
on shirts
you'll
and
you'll
shoes and
Google
all that stuff.
something and then you'll see an ad for it on Facebook,
Absolutely, it shows up. I
right?
sometimes I'm
Yeah,
not even on Facebook, and I'm on Google, and I go on Facebook, and I get an ad there. So there is something going
yeah,
on in there that I'm not quite sure.
yeah,
So
yeah. They're all in cahoots.
exactly. So that just tells you this massive amount of data that is getting generated, and I call it, it's a relentless, meaning there is no end to it. So right.
So
So
I wonder if there's some kind of metric where you tie the 400 gig
mhm.
pipe size,
Yes.
right? We're going to bigger pipes now, 400 gig. I wonder if there's something that ties the size of that pipe to the consequence if it goes down, like how many of these online shoppers get
Can
impacted,
impact it.
or
Yes.
how many of these IoT devices that you mentioned
Hmm.
can't work, or something that's
I don't have this.
a
Yeah.
magnitude of impact at the application
Sure.
level,
I think that's a really good
right?
point, and there's got to be
And
some
I
data
want if
around.
that's going
Yeah.
up, then that would mean like, okay, that's a reason why these 400 gig optics all of a sudden matter more than the 10 gig or 1 gig
I think
before.
you're absolutely right. There's got to be data. I'm pretty sure, Pat, there is a data that's available already, but it is very impactful, right? And it is impactful because your speeds are going. It's a multidimensional problem, right? Your speeds are going up, subscribers are increasing. Each subscriber is now
Mhm.
generating data on different devices. So all of that combined has an impact on the network, right? So even a single subscriber that you add to a network has an impact on the network, because you have to reshuffle resources. You have to obviously use the resources efficiently. All of that adds up. To
Mhm.
me, it is challenging, but clearly, like you said, it's more impactful. So, if you have a 400 gig port, you have a lot of subscribers on it, and you have a lot of
Mhm.
flows going through it. And that's why, if you look at it, our customers' number one concern has always been resiliency, and more than ever, how resilient your boxes are. What type of
Mhm.
resiliency schemes do you have inside the box and outside the network? Node redundancy, site redundancy, fabric redundancy, power redundancy, control plane redundancy. And that's exactly
Mhm.
why they have this, because you want to be able to um, uh, make your network resilient, because
Mhm.
it's becoming more and more important, right? How can you scale the network? How can you make it resilient? How can you make it fault tolerant? So if something goes wrong, you don't shut out. But still, we
Yeah.
do see cases. Just recently, there was a network that went out, and it took a while to restore it. And
Mm.
you don't realize the importance of something until it happens to you, and then you
Yeah.
realize how
That's
important
right.
that is.
You don't appreciate it
You don't
until it's
appreciate it.
gone.
So you don't appreciate
Yeah.
all the work that has gone into all these optics, and how durable, resilient, and qualified these optics are, until you run into a problem where it's. By the way, it's if an optics in a network is not behaving correctly, it's really challenging to isolate it. Right? Think about this.
Yeah.
It's very difficult.
Yeah.
It's a very difficult task to go out and figure out. I know of a case where an optics was misbehaving, and we had to do all the debugging, and it turned out to be a third party optic that was on a competitor box. So we
Mm.
know situations, and how difficult it is. And obviously, we were in the center of it all, meaning everybody
Mhm.
was like, Cisco, help us, and we stepped up and we did
So
the work.
what did you do? Because I heard the first step is you send someone out there and they just start unplugging cables,
Well, it
and
was
someone else says, "Hey, that's the right one," or "It's not the right one. Keep unplugging."
so exactly, that's
Mm.
one way to approach it, right? Brute force method. The other one
Mhm.
is to just isolate the problem, starting out with where the issues are, where this what type of issues you are seeing, and then just backtracking it,
Mhm.
through software,
Ah,
which
okay.
traffic is impacting, how is it impacting, what's happening. And so we were able to isolate it. It took us a while to do it, but
So you're able to do it kind of remotely without having
no,
to
I
send
think no,
someone.
we had people on site, if I remember correctly.
Okay.
It is complicated, and it was a transceiver that was a non-qualified transceiver, but it wasn't on our box. So uh, the thing that I am very proud of is the fact that at all levels, whether you're talking about systems or whether you're talking about transceivers, there is a tremendous amount of work that goes into it in terms of qualification and making sure that it comes up to our standard.
Yeah.
So we don't just simply, it's not like we do the bare minimum testing. We plug something in, test it, and say this is good enough.
What's the opposite of bare minimum? The overkill maximum? I think
we are almost at that level.
Yeah.
Sometimes I find that a little challenging because I wanted to get things out and I just could not because I had to wait until all the qualifications gates were met, and then we would have said. And we do the same thing with software.
I mean, that's always a fundamental trade-off.
Yes.
Right.
We do the same thing with software, right? So we have exit criteria.
Yeah.
If you FCS criteria. If you don't meet the criteria, you don't FCS. So same thing.
Yeah. Hey, so going back to this idea of bars. That was the fourth part of my conversation with Ammar Khan. Next time, we'll get into security features in the 8000 router. Subscribe to this podcast, and we'd really appreciate you helping to get the word out. Share this with friends and colleagues that come to mind when you think of network technology and optics. And leave a review on Apple Podcast. We're also on all the other major podcast platforms. You may see the Cisco Podcast Network come up when you search for Cisco Optics Podcast. That's where we live, and you can find other great podcasts there too. Also, check out the Cisco Optics blogs at blogs.cisco.com and search on hashtag Cisco Optics Blog. No spaces and no hyphens. We also have educational videos on YouTube. Just go to youtube.com and search on Cisco Optics. Thank you for listening. This is Pat Chow, Product Manager at Cisco Optics. The next episode is the fifth part of my conversation with Ammar Khan. Until next time.